Thanks for joining me, everybody. Glad you could be here tonight. I just got done reading a paper earlier today, and I just wanted to highlight it and go through it with you. It's just fascinating to me. If you follow me and you know anything about me, you know that I love supernova remnants. I love supernova. They're the end stage of a life of a star, and I find them fascinating because it's the universe's way of replenishing and spreading out elements that are needed for the creation of new stars, new planetary systems, even life itself. For example, the iron in our blood, it came from a supernova that exploded, and those elements formed into a molecular cloud that then condensed and formed our star, our sun, the planetary bodies, and that iron ended up here. And in the process of creation and moving everything along, the iron in our blood is a result of that supernova that exploded. So I just find them fascinating. There's a lot of other reasons too that I find them fascinating. Some of them happen really fast with massive stars. Others are white dwarfs that for some reason, whether they collide with another white dwarf, whether they take mass from a companion star, which are most of the stars in our galaxy and universe, and exceed that Chandra-Sakar mass limit of 1.44 and explode, obliterating the white dwarf, destroying it completely, or other ways that they pull material off a companion and end up exceeding that limit and exploding. Regardless of how, I just find them fascinating. I thoroughly enjoy looking at the remnants they leave. I actually think they're quite beautiful. Here, I haven't posted any of my sea star images, probably should, but these are just the sketches that I've done over the last probably 15, 16 years of supernova remnants. The first two on the far left and in the middle, those are two sketches of the western and the eastern Veil Nebula in the constellation of Cygnus. It's a beautiful eye candy supernova, whether you see it remnant, whether you see it visually, whether you sketch it like I did, whether you image it. It's just beautiful. A lot of intricate details and filaments that go with that one. It's fun to tease that out. The other one that's really wonderful and eye candy is on the far right there. It's Messier 1, the Crab Nebula, 1056 supernova in the constellation of Taurus. And you can see in this sketch, and I have additional sketches and additional information on this all over at Eadsy Astronomy. I highly encourage you to read the full article and to see the detail of my sketches by going over to Eadsy Astronomy and being able to look at them and see the details of them. I actually have two sketches of M1 there. This is the best one I've ever done. It was a night of nights, probably the best night I had in 3 years. I was out in the West Desert. I had an SQM reading that night, 21.92 to 21.94. It was just dark, dark, dark. To be honest with you, transparency was 5 out of 5. Seeing was 5 out of 5. Antonati 1. It was just gorgeous. Using the O3 and the narrowband filter and the right magnification, I was able to really pull out some great detail of that as I captured in that sketch. So, seeing eye candy, it's out there. One's in the summer, one's in the fall and winter, and these are just great supernova remnants to get to. The other ones I've seen are a lot fainter, a lot more challenging. Upper left, IC 443. It's a supernova remnant in the constellation of Auriga. Gemini, really Gemini. I put it in Gemini. Some people, I've seen it listed in Auriga. I really feel it's in Gemini. That's where I've seen it. I've seen details, filament structure. I've seen just a narrow band. Pretty easy to see, to be honest with you, if you know what you're looking for and where to look. The middle one is a composite image of 4 sketches, and I have those 4 sketches again over at Eadsy Astronomy if you want to take a look at them. This is CMS 147. This one is in Auriga, and it is a very, very ancient supernova remnant that's out there. Again, that's the composite. Off to the far upper right is probably one of my favorite objects. I go for it every fall. I sketch it every fall. It's Cassiopeia A. It's in Cassiopeia. It's a supernova remnant. Very faint, great challenge. I love the star hop. I always star hop to it, and I love the challenge of finding it, sketching it, and pulling out detail with it. I do that every fall now. It's just always on my list because I just get excited when I see it and to think about what I'm looking at there. Bottom one is a lesser well-known one. It's in the constellation of Cygnus as well, a summer one. It's Sharpless 2-91. Sharpless 2-91 is a supernova remnant, basically just a little bit north of Alberio. You can read the details of it over on Eadsy Astronomy. It's faint, but visible, and you can see it. I did 2 sketches on 2 different nights back when I took these, and confirmed that I saw it. It's well worth the challenge of seeing it. So some of these are really wonderful to see. Some of these are really challenging visually. They can even be a little bit challenging if you're imaging as well. However, okay, as great as this is to me, astronomers have found one that neither I nor any visual observer, probably no imager, are going to be able to visually observe it, sketch it, or image it. It's actually so faint that it almost was not even discovered. Here it is. Let's take a look at this. Okay, this is G. I'm going to just read it here. G 310.7-5.4, and it was recently named the Abeona Supernova Remnant. It's a supernova remnant that's basically located off the galactic plane. Most of these things are buried in the thick dust clouds of gas at the Milky Way's disk. Alberio is really out there in the suburbs. Okay, it's away from the disk, up in the upper plane. It was first spotted as a possible candidate many years ago, but it took the sensitivity of the ASCAP radio array in Western Australia to confirm that it was actually a supernova remnant. You can see it here on the image. It's a classic bilateral shell. Think of it as 2 glowing parentheses. That's what I think it really looks like here in space. And here's the kicker. It's also glowing in gamma rays. There's a source called, and I'll just read that one, 4FGL G1413.9-6705. It lines up perfectly with the shell's edge here. So gamma ray bursts, all that's there. It's remarkable as it really is challenging our detection limits and thresholds. And so it's really awesome that we've been able to discover this. Since it's off the galactic plane, there's not a lot of material for the shock wave from this supernova to slam into. Thus, it makes it really difficult, really faint to see. We're pretty sure the progenitor on this one was a type 1A supernova, so it came from a white dwarf. There's a couple of reasons why we believe that. There's more over in the paper. I'll just touch on a couple here to be quick. One, we haven't found a remnant. We haven't found a pulsar. Usually a massive star, when it goes supernova, it either leaves a black hole or a pulsar. Haven't found either. None of those are out there with this one. Also, because of that, we believe that the white dwarf destroyed itself in the type 1A supernova, which is typically what happens. And as it exceeded that Chandrasekhar mass of 1.44, like I said, whether it was pulling from a companion star, whether it was 2 white dwarfs merging, whether it was other ways that white dwarf exceeded the Chandrasekhar limit of 1.44, it exploded as a type 1A supernova, destroying itself, obliterating itself. Also, because it's so high in the galactic latitude, away from the galactic plane, out of that region of heavy dust, heavy gas, where typically the massive stars are born, we're pretty sure that this was a type 1A, resulting from a star similar to the mass of the sun, maybe just slightly bigger, could be out there, and it ended its life a couple thousand years ago. That's a type 1A supernova. And again, like I said, no pulsars found. Anyway, why does it matter to us? It tells us about the environment outside the main disk of the galaxy. So if we're looking edge on, main disk of the galaxy would be here where my fingers are, right? This is up in the galactic latitude up here, okay? It's outside of that main disk. It shows that these massive explosions enrich the space around them, even in low density areas where there's not a lot of material for that shockwave to plow into, okay? It's faint. It's a beautiful ghost of a star that ended its life, like I said, several thousand years ago. Fascinating stuff. Please head over to Eadsy Astronomy. Look at my sketches. Look at the images. Read the full article. There's a lot more information over there. Hit the subscribe button to subscribe if you like the content that we do. If you like it a lot, you can join us over at Eadsy Astronomy. You can sign up for a free membership. If you really like what we do and want to contribute and help us just to pay for some cost and materials and time, you can do the $3 or $5 level, but material here will stay free. And anyway, I appreciate that you stopped by and took a look. I hope you have clear skies and that you're looking up and wondering at the wonderful things that are up in our night sky. Thanks for joining me. We will catch you next time.